Welcome. In today's lecture, we will discuss fractional factorial design. I will introduce this concept introduction. So, you have seen earlier factorial, that is full factorial design, full factorial design. So, it is 2 to the power 2 design, 2 to the power 3 design, 2 to the power 4 design, as such 2 to the power k full factorial design. So, our job today is from full to fractional. It will be something like 2 to the power k minus p fractional factorial design. When we go for fractional factorial design from full factorial design, so there will be lot of changes, and there are conceptual issues, there are estimation issues, and there are design issues. So, all those things will be discussed in this introduction lecture on fractional factorial design, and subsequent lectures will show you the examples and the higher order calculations. Today we introduce this subject, this concept, and then I will go for 1/2 fractional factorial design, and then how the 1/2 fractional factorial design will be constructed. One example will be shown to you, and then there is another important concept called design resolution. Design resolution will be discussed. It may take time, but we will try. If not, otherwise in the next lecture we will start with design resolution. So, obviously you may be thinking that the lectures, if you see from the beginning to today's lecture, that initially we have started with several factors, and each factors with several labels, and then from there, like we have started with suppose factor A with A number of labels, B with B number of labels. So, like this k factors with k number of labels. Then from there we have reduced these labels to 2, A equal to B equal to C, all those things will be equal to 2. So, label 2. So, then 2 to the power k factorial design, that is evolved. 2 to the power k factorial design is evolved. We said that why 2 to the power k is required, because if we go for A label for factor A, B label for factor B, and as such there are many factors with many labels, then the number of treatment combination will become very large, and it is impossible for the experimenter to conduct experiment from the cost point of view, time point of view, resource point of view, and it will be so costly that maybe the it will be a feasibility issue also for conducting such experiment. So, we say that 2 to the power k factorial design, from full to 2 to the power k factorial design we have considered. So, these are all 2 to the power k factorial design. Now, even in 2 to the power k factorial design, suppose if k equal to 10, then 2 to the power 10 means it is 1024. So, these many experimental condition, these many experimental runs with single replicate is required. So, if I have k number of factors each at 2 labels, so you require a large number of experiment to be conducted. So, that means here also there is problem for experimentation, physical experimentation. So, what you require to do that? So, is there any other way to reduce the number of experimental runs without losing much the information that we want to achieve or the objectives that we want to accomplish? So, this is possible if you reduce the number of runs further, and that concept is fractional factorial design. Fractional factorial design. Okay. So, when we go for fractional factorial design, these are the situations. When number of factors become large, you cannot conduct large number of experiments. When the objective is to screen factors, so it is basically to see that which are the factors that are having effects, which are having not effect. So, to screen out the trivial factors from further analysis or experimentation. And when it is intended to get direction for further experiments. So, that means the fractional factorial design help you to find out that what are the key factors that are contributing, and at the same time it will tell you that in which direction you go for further experimentation, so that you will get better results when you go for fractional factorial design. Now, the next question is fine. So, when I have large number of factors, I want to screen out the factors and I want the future direction of experimentation, I will go for fractional factorial design. But then you may be interested to know what do we mean by fractional factorial. That is what I have not told you. So, I told you that if that 2 to the power k minus p fractional factorial design, that is what I told you. You just consider a case with 2 to the power 3 factorial design. So, how many treatment combination? 2 to the power 3 equal to 8 treatment combinations. Okay. So, then if I write the factors are A, B, then A B I can write here, then C, A C, P C, A B C. This kind of notation you have seen earlier. So, how many combination? 1, 2, 3, 4, 5, 6, 7, 8. If you recall, we say this is minus, plus, minus, plus, minus, plus, minus, plus. This one minus, minus, plus, plus, minus, minus, plus, plus. Then these two, when you multiply A and B, you get plus, minus, minus, plus, plus, minus, minus, plus. Then C will be minus, 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 plus, 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 plus. Okay. If you recall that I said that 2 to the power j minus 1 plus minus plus alternatively, when j equal to here 1, 2, here 3. This is first vector, second vector, third vector. So, 2 to the power 3 minus 1 means 2 to the power 2 with 4. So, 4 minus followed by 4 plus. Then what happened? A C, if you multiplied A and C, this is plus, this is minus, this is plus, this is minus, minus, then this one will be minus, this will be plus, this will be minus, plus, minus, plus, plus, plus. So, 1, 2, 3, 4, 4 plus 4 minus will be there. So, like this, what will be the A, B, C? If I multiplied A, B and C, then this is minus, then that means A, B into C. So, A, B plus minus 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 plus A B into C, minus minus plus plus minus minus plus 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 minus plus minus minus plus minus plus plus plus. So, minus minus okay 4 1 2 3 4 and B C minus 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 plus minus minus plus plus minus minus plus minus 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 plus plus minus plus minus plus minus plus minus plus minus minus plus minus minus, this also minus, then minus plus minus plus 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 plus. This is what is the algebraic that sign matrix what you have seen earlier. Okay. Now, here you do some kind of readjustment. Suppose you just keep A B C only plus one side top half and only minus. So, A B C plus 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 then minus 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 minus. This differentiation, this kind of difference you make, and then you will get a table like this. You see, this is the table. In this table, we create two halves for ABC, 4 plus with 4 minus. Now, let you will conduct experiments only with the combination A, B, C and ABC. Then what is the design? Design is 2 to the power 3 minus 1. So, or 1 by 2 to the power 3, that is known as half fraction. Okay. Suppose you have 4 factors instead of 3. Now, you consider 4 factors A, B, C, D. This will increase. So, treatment combination to the power will be 16. Now, suppose that you can run only 4 experiments, only 4. And if you do this, what are you doing then? 2 to the power 4 minus 2, that means 1 by 4 2 to the power 4, design you are implying, that is 1/4 fraction. 1/4 fraction. So, in general, that is why in general if we say that 2 to the power k minus p fraction means, that means 1 by 2 to the power p 2 to the power k. So, 1 pth fourth, that is pth fraction, mean 2 to the power pth fraction. This is the design. So, if I go by this way, you all know that the cube, the geometric view also you know, geometric interpretation you know. You that means in case of fractional factorial design, instead of taking all the factorial points for experiment, you split it into 2 halves, one half where you may be, depending on this, you may n plus another half So, 2 halves here A, B, C all positives, positive values, 4 positive here may be A, B, C's, all 4 negatives. So, any one half you can consider and conduct the experiment. So, that is half fraction. So, now if it is to the power 4, then if you want 1/4, so you are basically finding out 4 different parts segmentation. So, here if I consider in this case, if I consider this is my A factor, this is our B factor, and this side is C factor. So, then what will happen? Suppose if I start with this is 1, this is your A, this is B, and this one will be A B, and this will be C, this will be A C, and now this 1 minute. So, A B B C, then one more is there, B C is and A B C. Suppose if I go for, you see the slide now. So, if I go for A B C plus, then you are experimenting A B C and A B C. So, where is A? Your A, where is B? B, where is C? C, and where is A B C? This. Then rest, these are all plus, A B C plus, like this. So, rest will be A B C minus, where this, then this one, and this one. This is called 1/2 of 2 to the power 3. Now, if you say 1/2 of 2 to the power 4, then what will happen? There will be one more factor D, and D, suppose this is for D positive, similarly another one will be for D negative, and you will be doing it. So, in general, when you make it to the power k minus p, that is known as 2 to the power k minus p fractional factorial design. Okay. So, then what we have said? We have said so far that 2 to the power k full factorial design may not be possible in many situations, particularly when you have large number of factors. Under such situation, if the objective is to screen out the factors and to find out further direction of experimentation, then you can adopt fractional factorial design. Fractional factorial design, the concept is that there will be some ways to identify less number of experimental runs, and one of the ways we have demonstrated here, considering A B C all plus and all minus. Although I have given this arbitrarily, that why all plus and all minus separately taken out. So, that mathematics I have not said, or that concept I have not discussed so far. I will discuss this, but please keep in mind that there is a scientific way to find out a fraction of the full 2 to the power k factorial design. That fraction can be half fraction when p equal to 1, p equal to 1/2 fraction, p equal to 2, then it is 1/4 fraction. So, like this 1/4, 1/5, and p equal to p 1/5. Okay, so, this is what is known as fractional factorial design. To repeat it again, if you have 2 to the power 3 factorial design, it is the rule that you will conduct experiment in all the factorial points. If you cannot conduct experiment on all the factorial points due to resource crunch, you go for fractional factorial design, and there instead of all the corner points, factorial points, you choose 1/2 of this or 1/4 of this. 1/4 here is not good one, but 1/2 of these and this, then you will be doing experiment on selected point factorial points. So, that is known as fractional factorial design. So, how you come to the factorial points where experiment will be conducted is an issue, and here using ABC all positive and all negative, we have shown the split of this to the power k factorial to the power k minus 1 factorial design. Okay. Now, you will be interested to know that if I split this the to the power k factorial points into to the power k minus p factorial points. So, you are after doing experiment. So, that means you will not do experiment on both the split, you will do experiment either here or here. If you do both, actually you are doing the same thing again. So, that is why you will take one of the two. So, question is that means 4 different important treatment combinations are not considered. So, then if I do not do experiment all these 4 in reference to this example in the 4 different points like this and this. So, I will be losing information. So, if I lose information, then how do I conclude from the results or how do I analyze the experimental data and subsequently conclude from the analysis that what are the factors that are affecting, what are the factors that are not affecting. So, there will be errors or there will be concerns. So, then your question will be, then how does fractional factorial design works? Why fractional factorial design works? That is an important issue. Fortunately, we have some important properties and that will help us conducting fractional factorial design. What are those properties? First property is the sparsity of effects principle. This is the first. What is the sparsity of effect principle? If you have large number of factors, suppose you have k number of factors, let k equal to 4. Then how many main effects? Main effects will be A, B, C and D. How many two-way interaction effects? Two-way interaction will be AB, AC, AD, BC, BD, CD. How many three-way interaction effects? ABC, ABD, BCD, ABC, ABD, ACD, ACD, BCD. How many four-way interaction effects? A, B, C, D. So, we know this will be k equal to 4, this will be 4 C 2, this is 4 C 3, this is 4 C 4. So, 4 C 2 means 4 into 3 by 2, it will be 6, 1, 2, 3, 4, 5, 6, this will be 4 and this will be 1. So, 6 plus 11, 15 interactions will be there, 15 effects. So, the sparsity of effects, so there are 15 effects, some are lower order effects like main effects, lower order interaction effects and then higher order interaction effects. Sparsity of effect principle says that in general the higher order interaction effects are negligible. What does it mean? The contribution of higher order interaction effects on the responses will become negligible. So, you may not, given a situation, you may not estimate this third and fourth order interactions. So, now you require 15 effects to be estimated. if you do not do third and fourth order, that means 5 different effects you do not require to estimate. So, as a result, even with less number of experimental data, you will be able to conduct some analysis and get some useful results. Second principle is the projection property. What is this projection property? The projection property means if suppose you consider a to the power 3 design. Now, you consider you are not able to do all runs. So, you are going for to the power 3 minus 1 design. Although, in to the power 3 design case, this is fractional, but this is not fractional in 2 dimensions. In 3 factor case simultaneously it is fractional, not giving you the full, but if you project into the lower dimensions, then it will become full to the power k factorial. So, that means what do you mean? That means you have full information or from the factorial point of view in the lower dimension, even if you do fractional factorial at the higher dimensions. So, that is the projection property, means in lower dimensions you have full information to get all the effects at lower dimensions. And the third property is sequential experimentation. What does it mean by sequential experimentation? The sequential experimentation means here this 2 to the power 3 design you split into 2 to the power 3 minus 1. Let you have done experiment with this, the first half, and you got some results. You may not be happy. In that case, what happened? You require conducting another experiment. So, you consider the second part. So, after conducting the second part experiments, when you combine the two, you have this full. So, this is what is the usefulness. Suppose when I conduct the first one and you are happy with the results, you do not require to go for the second one, because you are screening as well as for further experimentation point of view the information you got from this. If you do not get from this, you go for the other half, and then these two combined will give you the full one. You have complete information as in terms of 2 to the power k factorial design. So, these 3 properties enables the experimenter conducting fractional factorial design, because this will give useful results. It is not arbitrary, it is a good one. Now, I come to that another one, that one very important concept called that how defining relations, okay, or generator. So, you see this table 2 to the power 3 minus 1 d. So, and this is basically 2 to the power 3 full design. Now, we have written ABC in a special manner, so that you will get all 4 positives first, followed by 4 negatives. And if you see this table, there is one column called I in the, and if you see the symbol in I and ABC, both are same. Here plus 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 plus, here plus 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 in the first half. So, we can say I equal to ABC, I equal to ABC. Okay. Now, beforehand or other way I can say that in earlier example I have shown, suppose if I multiplied this I into C, if I say C A C I, then you will multiply this A B into C means C square, C I A C is equal to A B, because C square equal to I, C equal to I. So, that means if you see the plus and minus sign in the table, so you see that C equal to A B, because C is minus 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 plus 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 plus, C equal to A B. So, if I do 1/2 here, so my design matrix or the factorial effect matrix will be, suppose let us consider the top one, let it be. So, A B C A B C, then I plus 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 plus, then your A, it is plus minus minus, sorry, plus minus minus plus, then B is your minus, then followed by plus, followed by minus, followed by plus, then your AB is minus, plus minus minus, plus plus, then C is your minus minus plus plus, so minus minus plus plus, AC is minus plus minus plus, BC is plus minus minus plus, and ABC is plus 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 plus. Okay. So, interesting pattern you see in the contrast, and you all know that this multiplied by this will become give you the contrast. Suppose A, here minus, C A plus, see the BC part, plus, minus 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 minus, plus plus. So, that means the contrast for these as these are same. So, that means what will happen here, you cannot estimate A and B C separately, they are confounded. Second one, if you see B and AC, you see B and AC, minus minus plus plus minus minus plus plus, they are confounded. Similarly, these two are that these two confounded. That means, if you do 1/2, you will not, with this you will not be able to estimate all the effects uniquely. Some of the effects will be confounded with others. This is known as alias structures, alias. Okay. And here this concept I equal to ABC, this is called the generator of a particular fraction. So, this half is created considering I equal to ABC. If you consider I equal to minus ABC, you will create the another half, where things will be another half will be AB, AC, BC and 1. These few we have not considered, and all those things will be there. There what you will find out I all plus, but when you go for ABC here, they will be all minus. So, that means this is a very important concept called generator. This generator helps you in doing the fractionalization. And when you do such fractionalization, such kind of fractional design, what will happen? You will see that you are not in a position to uniquely estimate all the effects. Some of the effects are confounded with some other effects. Okay. So, with this I conclude the first lecture, and so what we have discussed so far, we have discussed that what is fractional factorial and why it is needed. How does it work, and how to generate fractional factorial design. So, in this process also I talk about that generator, talk about aliases, talk about confounding, and all those things we have discussed. In the next lecture, I will show you that the estimation part, effect estimation part, the with an example, and the design resolution with reference to fractional factorial design. Thank you very much.